Now we will solve another problem using nodal analysis. Look at this problem. It is a little bit different from the previously done problems. In all questions we have solved using nodal analysis contain only current sources and resistors. But look at here. Here you have a voltage source and current source and resistors. So, and see, this voltage source is present between two non-reference nodes. So such a problem we cannot solve by using the previous way of nodal analysis. So here we have to use the concept called a supernode. Supernode means if there is a voltage source present between two non-reference nodes, that is called supernode. So it requires the application of both Kirchhoff's current law and Kirchhoff's voltage law for solving the problem. In all our nodal analysis problem, we have solved by using Kirchhoff's current law. You are applying Kirchhoff's current law at each nodes and then solving that equation. But if there is a supernode present, we cannot rely only on Kirchhoff's current law. We have to use Kirchhoff's voltage law also for solving your problems. So the steps of the problem that remains same like your nodal analysis. The very first step is identify the number of nodes. Look at here, how many number of nodes are present here? See here, this 4 ampere current source and this resistor 1 by 2 ohm resistor and this 5 volt current voltage source all are meeting at this point. So this can be considered to be a node. So 4 ampere current source, this resistor, this voltage source. So this I am just marking as node number say 1. Now see here, this 5 volt source, 1 by 6 ohm resistor, 9 ampere current source, all are meeting at this point. So this can be considered as another node. So I am marking it as node 2. 5 volt, 1 by 6 ohm, 9 ampere. Now, all the four things here, 4 ampere, 1 by 2 ohm, 1 by 6 ohm and 9 ampere current source, all are connected to the ground. So this can be considered as the bottom or ground as the node number 3. So here 1, 2, 3, 4 elements are meeting. Now what is the second step? So we have identified now the first step, number of nodes. There are 3 nodes are there. Now second step is select bottom node as reference node. So this is the bottom node. Now we have to consider this as the reference node. That means we are assuming the voltage at this point is equal to 0. So this is called as the reference node. Select bottom node as reference node. Now our third step is to draw the nodal diagram for this. So for drawing nodal diagram means we are going to more focus on the nodes and based on that we will redraw the circuit diagram. So we will first draw the number of nodes. 3 nodes are there, node 1, node 2 and node 3. Between node 1 and 2 you have a 5 volt source. So this is node 1, node 2 and node 3. Between 1 and 2 you have a 5 volt source plus minus 5 volt. Between 1 and 3 we have 1 by 2 ohm resistor. Between 1 and 3 we have 1 by 2 ohm resistor. Between 2 and 3 you have 1 by 6 ohm resistor. Again, between 1 and 3, again you have a 4 ampere current source. So between 1 and 3, again you have a 4 ampere current source. Direction of current source is upward, it is 4 ampere. Between 2 and 3, you have a 9 ampere current source. The direction of current source is again shown upward direction. It is 9 ampere between 2 and 3. So this is our nodal diagram for this circuit. Now look at here. At the node 1, we have 3 branches. Node 1 meets 3 branches meets at node 1. 4 ampere current source, 1 by 2 ohm resistor, 5 volt. Node 2, 5 volt, 1 by 6 ohm resistor and 9 ampere source. And node 3, it is the ground node. So this is corresponds to the nodal diagram. Here we are more focusing on nodes and we are redrawing the diagram. Now our next step is assign voltages. So for the node 1, I can assign the voltage, say V1, say V2, and node 3, that is the reference node, I am going to assign, say V3. This is the reference node. So these are the 3 voltages, and look at here, V1 and V2 are the 2 voltages of 3 non-reference nodes. That's only we need to find here. So the the 2 voltages at the non-reference node, V1 is unknown to us, V2 is unknown to us, and V3 is reference node, it is equal to 0. So that already we are considering as 0 potential. Now our next step is to apply Kirchhoff's current law to each non-reference node. So here this is a non-reference node and this one is the second non-reference node. So if you are applying Kirchhoff's current law to the first non-reference node, what is Kirchhoff's current law? All the currents meeting at a point should be equal to 0. That means the current leaving a node should be equal to the current entering the node. See here, if I am taking this node, 3 elements are meeting here. Here you have a current. To this resistor, I can find the current as voltage divided by this resistor. But what about the current in this branch? Here, no, it's not provided any current. You don't have a resistance. Only provided is a voltage value. So we cannot apply Kirchhoff's current law here because these 2 branches have current, but this branch does not have any current shown. So if this current is not shown here, to this node alone I cannot apply Kirchhoff's current law. Now look at this node. If I want to apply Kirchhoff's current law over here, see this a current source coming here. This branch I can find the current. What about this branch? Here again the same. There is no current given, only the voltage source. And that voltage source is common to these 2 nodes. So this voltage source is going to be common as for these 2 nodes. So here this node alone also I cannot apply Kirchhoff's current law. So what is the concept I am going to use here? A super node, because as there is a voltage source between 2 non-reference node, we have to treat this both node as a single node and we need to apply Kirchhoff's current law. And that single node is called as the super node. So this node, these 2 nodes together I am going to call it as a super node. So super comes, that means it is having something more in that. So symbol node you know. Now 2 nodes together is going to be considered a single node and that is called as super node. So what we have to do here, treat it as both nodes together as a single node. Apply your KCL here. It is same way. All the currents meeting at this super node should be equal to means equal to 0. All current entering to the supernode should be equal to all current leaving that supernode. So these two nodes together we are considering as a supernode. We don't want to consider this element when we are writing the KCL of supernode. So we have here this and this node together as supernode. We have 1, 2, 3, 4 elements only. This is between that we don't want to consider. So here the we are writing the KCL here. We can write it as this current is V1 divided by 1 by 2. Assume that all the resistors currents are leaving. All the resistors currents are leaving. So V1 divided by 1 by 2, and this is a current entering. So it should be minus 4. For this one, if I am considering, this is leaving. So the current will be V2 divided by 1 by 6, and this is entering. Minus 9 should be equal to 0. Now readjusting the equation, I can write it as this 2 will go up. So 2V1 and minus 4 plus 6 will go 6V2 minus 9 should be equal to 0. Take the constant term to the right side. You will be getting as 2V1 plus 6V2 should be equal to 9 plus 4 is 13. So this is take as equation number 1. So now we considered both the nodes and we got only one equation and two unknowns. So we need to get a second equation also. So for that we have to consider here, see, V1 and V2, the two different voltages, and between that you have a 5 volt source. So in this one you need to apply your Kirchhoff's voltage law. Between these two we have to apply Kirchhoff's voltage law. So V1 is here, V2 is here, in between no other elements other than a voltage source. So we can write this as V1 minus V2 should be equal to 5 volt, because plus is here near to V1 and minus is towards the V2 side. So we have to write it as V1 minus V2 should be equal to 5 volt. So V1 minus V2 is 5 volt. See, V1 this is plus and towards the V2 the minus. So this I can treat as equation number 2. So we got two equations. Now only we need to solve these equations. So these two are the symbol equations. You can solve it by using either simultaneous equation solving or by using the matrix method. I am more comfortable with matrix method, so I'll be using that. So you can write the coefficient of this one in the matrix form and find the determinant delta. Delta you'll be getting as 2, 6, 1, minus 1. You can write it as minus 2, minus 6. It will be minus 8. Get delta 1. Delta 1 is equal to, replace the first column by the 13 and 5. So 6 minus 1 you'll be getting as minus 13. 6 into 5, 30. Minus 30. So it is minus 43. Delta 2, we have to replace the second column by 13 and 5, be getting it as minus 3. So now we can calculate V1 and V2. V1 is delta 1 by delta minus 43 by minus 8, we will be getting as 43 by 8. V2 is delta 2 by delta, that is minus 3 by minus 8, we will be getting it as 3 by 8.